Okay, welcome to Pons University. Today we're going to talk about using substitution to solve a system of equations. This is with two variables. Okay, sorry again about the little glare on the board, but we will make it work. Okay, so the first one we're going to look at, remember we're solving this using substitution. They give us one equation here and a second one here. Okay. Now they tell us in the second one that y equals 3x minus 1. So that means that these two are the same thing. Y equals that. So keeping that in mind, wherever I see a y, I can replace it with 3x minus 1. So if I look up here at the first one, I have a y there. So instead of putting a y there, I can replace it with 3x minus 1 because they're equal to each other. Okay, performing that substitution, 8x stays the same, plus 2. Now remember, instead of y, I'm going to substitute in 3x minus 1. And that equals negative 16. So instead of y, I substituted in that 3x minus 1. So this here is equal to y. Okay? Just made a simple substitution. Okay, well now I can solve for x. Do some distributing. 8x plus 6x minus 2, distributing that 2, equals a negative 16. Combine like terms. Add 2. Okay. Now we can divide by 14. So x equals negative 1. So what I'm saying is in this system of equations over here, x equals negative 1. So now I just need to find y. Well, if I know that x equals negative 1, I can do the same concept I did with y and substitute this wherever I see an x. If I look at this equation here, it tells me y equals 3x minus 1. So what it tells me y is if I could tell what x is. So I'm going to substitute that guy in for x and find y. So I get y equals 3 instead of x, put negative 1 minus 1. Remember, we just took x. We put it right there. Okay. Y equals negative 3 minus 1. Y equals negative 4. So my ordered pair would be negative 1, negative 4. So what does that mean? Well, good question. Let's say you were to graph these two lines. Those two lines would intersect at this point right here. Okay. So that's how we solve using substitution. Not always is it going to be solved like y equals this. Okay, so let's look at a case where that's not the case. Okay, sure to write this down. Okay. So now here's a problem. It doesn't tell us y equals this, x equals this. It gives us two things that are in standard form. Two equations that are in standard form. Okay. So we saw last time it was easy to substitute if we knew what one of these variables were equal to. So we're just going to solve for one of them. Now we've got to pick an easy variable to substitute for? Well, if you look at negative 4x, there's a negative 4 in front of there, so eventually I'm going to have to divide by that. Okay. Negative y, not too bad. Negative 4y, again, have to divide by negative 4. But you see x, it's all by himself. Little 1 in front of here, life is good. So let's try solving for this x here. So I'm going to add 4y. Now I know that x equals negative 22 plus 4y. And this is going to use the same thinking. This is just like the problem we just had. Wherever I see an x, I can replace it with negative 22 plus 4y because they're the same thing. So if I look at my original, I can't use this one again. If you were to substitute it into this equation, you're going to get an identity at the end. So usually what I like to do, I just kind of cross that guy out so I don't make that mistake of substituting it in again. So we're going to take this and substitute it in wherever I see an x. It's now negative 4. And now instead of x, I'm going to substitute in negative 22 plus 4x. Or sorry, 4y. So instead of x, I substituted this in. So that's another way of saying x. Okay? Then minus y equals 3. So again, this is just x. That's the way of saying it. Okay, now I can solve. Distribute. You get 88 minus 16y minus y equals 3. Combine like terms. Oops. Okay. Subtract 88. It's negative 17y. Negative 5. And now we divide. Hopefully we're not running out of room here. That's going to be what? 5. Okay. Okay, so we see that using substitution, we were able to get our y value of 5. Now to get our x value, we could take that y value and substitute it wherever we see a y with 5. And again, remember, you could use any of the equations that we got. But this one here tells us x equals all that. It tells us what x is if we could tell it what y is. So why don't we use that information, take this guy here, and substitute him in for y. So now I have x equals negative 22 plus 4, and instead of y, now I'm going to put a 5. So x equals negative 22 plus 20, x equals negative 2. And then finally, we just write our answer as an ordered pair, negative 2. And that's how we solve a system of equations with two variables using substitution.